Hello, welcome back to Learn Physics. In today's topic, we are discussing about the previous year question paper only, new set of question. So last one question paper we finished, and this is the second set. That is, in that first question is, draw equipotential surface of an electric dipole. Okay, what is equipotential surface? Potential remains constant. Potential is same on the surface. Okay, if I am considering a charged conductor, the surface of a charged conductor, if I am considering, which is in equilibrium, then it will be an equipotential surface. Isn't it? So here we should draw the equipotential surface of an electric dipole. Electric dipole means it will be having a positive charge and a negative charge, isn't it? So how the equipotential surface will be? It will be closed like this, isn't it? One positive and the other is negative, like that it will be. Suppose if it is a uniform electric field, equipotential surface, many questions asked in many years there's relating to equipotential surface. If it is a uniform electric field, how the equipotential surface, how we will be drawing the equipotential surface in a uniform electric field? See, like this. And a uniform electric field, right? So we will be drawing a parallel lines. Okay, like this parallelly we will draw. Okay, and if it is one positive and one negative charge, this means how we will be draw. So this is for an electric dipole, one positive and one negative. The center, while we are considering, that is equal to 0. But if both are positive charges, how the equipotential surface will be? It will be coming closer to each other, isn't it? See here, this is positive and this also a positive. Then while drawing the this one, it will come very closer to each other. Okay, it will come closer to each other and it will be like this we will be representing, isn't it? So that is for a positive, both are positive means. If one is positive and negative means it will be like this. And in a work done in equipotential surface, that will be equal to 0. Work done will be equal to 0 in the case of an equipotential surface. That is the reason here it will be both electric field and the potential will be normal to each other. Isn't it? Otherwise, work done won't be equal to 0. Okay, work done will be equal to 0 in the case of a equipotential surface because electric field, and that is why electric field and potential will be normal to each other. Okay, so that is about the equipotential surface. But here it is asked, draw equipotential surface of an electric dipole. Dipole means positive and negative charges separated by a distance. Okay, so next is second one, a proton is accelerated through a potential difference V subjected to a uniform magnetic field acting normal to the velocity of the proton. If the potential difference is doubled, how will the radius of the circular path described by the proton in the magnetic field change? So we should know that relation connecting the radius and the potential, magnetic field, everything, because it is given, it is in a uniform magnetic field acting normal to the velocity. So path, how it will be? Circular path we will be considering. So BQV equals mv square by r. From that we will find out an equation for r, remembering, right? So that one, r is equal to, for the second question, r is equal to 1 by b root 2mv divided by q. Okay, so this is the formula for radius r. Okay, so the circular, how will the radius of the circular path described by the proton in the magnetic field will change? Radius, how it will be changing if potential is this doubled? If V equals 2v, b dash equals 2v, then r dash will be equal to 1 by b into root of 2m into 2v divided by q. So r by r dash by if I am or r dash by r if I am considering, what I will be getting? I will be getting it as root 2. Okay, root 2 times the previous radius. Okay, it has increased by a factor, increased by root 2, the new radius. So this one you should know, dqv equals mv square by r. In a circular path, it will be describing a path of an electron if it is present in a magnetic field. Okay, remembering, right, that equation, dqv equals mv square by r. Using that derivation is there. From there we will find out the value of r. R equals 1 by b into root 2 mv divided by q. If voltage is doubled, what is the difference which you are feeling over there? This will be root 2 into v. Okay, like that it will. So one root 2 is increasing in the case of the new radius. New radius will be increased by the term root 2 times the previous radius. Okay, then now the third one. Now the third one is the magnetic susceptibility of magnesium at 300 Kelvin is 1.2 into 10 to the power 5. At what temperature will its magnetic susceptibility become 1.44 into 10 to the power 5? So magnetic susceptibility is given, temperature also given. What is the relation connecting magnetic susceptibility and temperature? It is Curie's law, isn't it? In Curie's law, the magnetic susceptibility is inversely proportional to temperature. Okay, so here third one, magnetic susceptibility is inversely proportional to absolute temperature for a paramagnetic substance. Okay, so here in this case, first one, at T equals 300 Kelvin, chi is given as 1.2 into 10 to the power 5. Okay, then the temperature will what will be the temperature? We should find out this one I am giving it as T1 chi 1. So here T2 we should find out. Chi 2 is given as 1.44 into 10 to the power 5. How we can find out? Chi m into T is a constant, isn't it? So chi 1 into T1 will be equal to chi 2 into T2. So here T2 we should find out chi 1 T1 divided by chi 2. Chi 1 is 1.2 into 10 to the power 5 into 300 divided by chi 2 is 1.44 into 10 to the power 5. Okay, while you are solving this, you will get the answer 36 360 divided by 1.44. Okay, while solving you will get the answer. Okay, understood that much of unit is in Kelvin. Okay, clear? So the next one is the magnetic susceptibility of a given material is minus 0.5. Identify the magnetic material. See here this is an OR question. Okay, magnetic susceptibility is given as minus 0.5. Okay, so what if chi is less than 1? If chi is less than 1, which kind of material it is? It is a diamagnetic material. It will be a diamagnetic material. Diamagnetic material if chi is less than 1. Okay, if chi is greater than 1 and nearly equal to epsilon. Epsilon means a value, a very small positive quantity, this epsilon will be. Then it will be a paramagnetic substance. Okay, if chi is 0, greater than 0 and less than epsilon. Epsilon is a small, which is a small positive quantity. A small positive quantity, that is very important, because if chi is very much greater than 1 means we will consider it as a ferromagnetic substance. Okay, if this is the case, if small positive quantity means it will be a paramagnetic substance. Okay, so clear, right? So the next one is fourth one. Identify the semiconductor diode whose VI characteristics are as shown. Okay, so this one here, it is volt, and this one is in milliamps, and here it's given like this, and here I1, I2, I3, and I1 is greater than, I2 is greater than I3. Okay, here it is in microamps. How, which kind of photodiode is, semiconductor diode is this one? This is a photodiode. This is the, remembering, right? Photodiode means when light of sufficient frequency is falling on the metal PN junction diode, what will happen? The light will be emitting. So, okay, a photodiode, because of when light is falling on it, it is conducting, not light will be emitted when light is falling on the photodiode. Photo, that is light is falling on the diode, what will happen? It will start conducting. Okay, such kind of diodes are called photodiodes, which will be working under reverse bias condition. Okay. Fifth question, which part of electromagnetic spectrum is used in radar? Give its frequency range. Okay, in radar, which kind it is using? In radar, it is using microwaves. Okay, microwaves, and its frequency region is from 10 to the power 10 to 10 to the power 12 hertz. Okay, so then it's an OR question next. How are electromagnetic waves produced by accelerating charges? If accelerating charges are there, means it will give an oscillating electric field. This oscillating electric field will be providing an oscillating magnetic field, that will again produces an oscillating electric field, and the process will go on. Okay, so the accelerating charges will be producing an oscillating electric field, and that oscillating electric field will be giving an oscillating magnetic field, which will again produces an oscillating electric field, and the process goes on. Okay, so that is how accelerating charges can produce this what is that, electromagnetic waves. Okay, then next one is section B, sixth one. A capacitor is made of two parallel plates, each of area A and separation small letter d, is charged by an external DC source. Okay, then show that during charging the displacement current inside the capacitor is same as the current charging capacitor. So what will be, see, a capacitor is there, means how the charge will be current will be producing due to capacitor and the displacement current, isn't it? Because of both. Okay, C means it is the conduction current, and ID means it is displacement current, right? Okay, so the total current is the sum of the these conduction current and displacement current. So outside the capacitor, ID will be equal to 0, because displacement current won't be there. Then I will be equal to IC, and inside the capacitor IC will be equal to 0, because therefore I will be equal to ID. Okay, so this is how we can show that during charging the displacement current inside the capacitor is equal to, so displacement current inside the capacitor will be equal to IC, and if it is not charging the capacitor, then it will be equal to ID. That means it is equal to same as the current during charging. Okay, then next is a photon and a proton have same de Broglie wavelength lambda. Prove that energy of the photon is 2m lambda c by h times the kinetic energy of the proton. Okay, so a photon and a proton have same de Broglie wavelength lambda. Seventh one, here we should prove that energy of photon equals 2m lambda c by h times energy of in proton. Okay, so we can find out energy of photon and energy of proton, then we can divide those two. So we will be if we are getting this answer, we can prove that. Okay, so energy of photon, what is the value of energy of photon? H nu. Okay, so we don't want nu, but we want that in terms of lambda and c, so I can write it as hc by lambda. Okay, now energy of proton, kinetic energy of proton is equal to half mv square, but we know that lambda equals h by p. Okay, h by mv, v equals h by m lambda. So E proton equals half m v square means h square divided by m square lambda square. M and m will get cancelled. Okay, so here both are in terms of m, lambda, h and c, right? So this is equation 1 and this is equation 2. I can divide E photon divided by kinetic energy of proton. Okay, that is equal to hc by lambda into 2m lambda square divided by h square. 1 lambda will get cancelled. 1h and 1h will get cancelled. So we will get it as 2mc lambda by h. Okay, so here this is the way. So whichever the equation which we know, using that only we derived everything, right? So here how we can correlate these two equations, that only you should find out. Okay, clear? So now then, eighth question is, a photon emitted during de-excitation of electron from a state n to the first excited state in a hydrogen atom irradiates a metallic cathode of work function 2 electron volt in a photocell with a stopping potential of 0.55 volt. Obtain the value of quantum number of the state n. So a photon is emitted during de-excitation of electron from a state n to first excited state. Okay, irradiates a work function, metallic cathode of work function as 2 electron volt, stopping potential as 0.55. Obtain the value of quantum number. So here this is 8th question. So exciting from nth state to first excited state. Okay, first excited state means n is equal to 2. So we know that En is equal to minus 13.6 divided by n square. Okay, so here E2 equals minus 13.6 divided by 4. Okay, so this one we will get it as 3.4 electron volt. Okay, so here metal is having a work function of, so 50 equals 2 electron volt and stopping potential is equal to 0.55. Okay, we know that h nu equals h nu 0 plus ev 0. Okay, so h nu equals 50, that so if it is ev0, this will become ev. Okay, so that is 2 plus 0.55, that is ev0. Don't write here and here e, simply if we are not writing, ev means 1.66 into 10 to the power minus 19, we are multiplying, so this also became an electron volt. Okay, so that is because in the question it is given as 0.55 volt only. Okay, now it became 2.55 electron volt. So what is the energy difference which we are in the state? Energy difference in energy is, energy difference will be equal to minus 3.4 minus 2.55 electron volt. So this one 3.4 minus 2.55 means it will be 0.85. Okay, so minus 0.85 electron volt. This is the change in energy. So minus 0.85 equals minus 13.6 divided by n square. So n square equals 13.6 divided by 0.85. That's 13.6 divided by 85. So here you will get it as 16. So n you will get it as 4. Okay, this is how we will be finding out this one. So from nth excited state to first excited state, how we are finding out the value. Okay, clear? So the next one is that is an OR question. A hydrogen atom in the ground state is excited by an electron beam of 12.5 electron volt energy. Find out the maximum number of lines emitted by the atoms from its excited state. Okay, in the ground state is excited by an electron beam of 12.5 electron volt. So here energy in the excited level, okay, excited is having an energy of 12.5 electron volt. Okay, energy in the ground state, how much it is? Minus 13.6 electron volt. Okay, in the ground level. Okay, so here or in the ground state means first n is equal to 1. Okay, so first excited state, it is going to this excited state. So what will be the energy difference which they are feeling? Minus 13.6 plus 12.5. So we will get it as minus of minus. So it is plus. So here 1.1 electron volt it is. Okay, so excited state, what is the difference in energy? That is difference in energy level is 1.1 electron volt. So minus 13.6 by n square equals 1.1. So what will be n square here? 13.6 divided by 1.1. So here you will get it as, so maximum 12. So n will be nearly equal to see 3 point something we will get. Okay, so maximum number of lines it can emit as 3 number of lines, n is equal to 3. So from third to second, third to first excited level, and third to which is ground level. So maximum number of lines is 3 lines it can be. Okay, here this understood, right? Usually the children will be getting doubt in the subtraction. Okay, this is the only thing which they are feeling difficult. So these kind of questions you should repeatedly do it, then only you can and see you will be familiarized with the more questions if we are attempting the question papers, because already most of the schools their pre-boards are over. First pre-board, second pre-board, third pre-board and all over. Now it is revision time for you. So better you can do the with the revise with the question paper. Don't wait for me. I am just telling an option how you can improve your score. Okay. So I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.